Okay, hello. My name's Glenn. My talk today is the rise of the dynamic edge, or another way to talk about it would be the past, present, and future of front-end hosting. If you don't know me, my name's Glen Maddern. That's me on Twitter. That's probably the easiest way to get in touch. I've done a couple of open source projects in the React space, a couple on styling, CSS modules, and styled components. More recently, a couple of years ago, I switched gears and started thinking about production performance and deployment, and started a project called Front-End Application Bundles, or FABs, which is at fab.dev, as well as a product around deployments called link.sh. Fairly excitingly, last year, Link was acquired by Cloudflare Workers. I've only been there a couple of months, but now I get to kind of approach the same problem, but from a point of view of an entire platform, an entire global platform, which is pretty exciting. So today I wanted to drill into something that I found really interesting over the last few years, getting into this stuff, which is how we've come to depend on and how CDNs have become a part of our front-end app workflows. So just to recap, a traditional CDN architecture has the CDN in between your users and your origin server, your actual host. And requests flow through and responses flow back. The CDN will take copies of those requests responses depending on some algorithms, some directives, but your origin server is the ground truth. So why do people use CDNs? Well, they're everywhere, right? This is Cloudflare's network. It's over 200 locations. But it might be a little bit surprising to just see just how important that geographical distribution is. Like, why do they need to be in so many locations? So I wanted to start today's talk by looking over something I'd actually looked at a couple of years ago, which is about the impact of latency. This was an experiment I ran for a web series I was doing called Front End Center, where I ran a bandwidth test or a download speed test from Melbourne, where I was living at the time, against 3 different locations: Sydney, San Jose, and London. Now, Sydney's only 15 milliseconds away, San Jose is on the other side of the Pacific, and London is 280 milliseconds by speed of light, or as I live there now, it's a lot longer by plane, let me tell you. So when you have a small file, you get download speeds or total download times, pretty much exactly what you'd expect. It's just one single round trip to the server. So if the server is away, the longer it takes for the file to download. But what might be surprising is just when you have a fast connection to a local box, and then this is between 2 data centers, so there's no bandwidth constraints here at all, really. For a 250 kilobyte file, we're still a fraction of a second. But when you add some latency into this picture, things start to get pretty different. At 200 kilobytes, you're now looking at 2 seconds in the best case scenario to download that file. And if you double the latency, the same effect is doubled. Now, this might be surprising because those servers are only 100 or 200 milliseconds further away, and yet the download times are taking 10 times longer, or 30 times longer in some cases. And these steps are actually the latency between those hops. So each jump on the graph is 160 milliseconds. Each jump on the red line is 280. This is because of the way TCP, the protocol, works underneath everything else, where it starts slow and ramps up as it detects that the network conditions are good enough. This means that the first 100 kilobytes cost a lot. That every 100 kilobytes from then on can increasingly cost your performance, and much more so than you might think. So being local is really important. This was actually in a video called Why Latency Matters, which was episode 10 of Front End Center. It's also out on YouTube. If that information is new to you, I encourage you to check it out. I go into TCP stuff as well. But for now, I'm going to change gears slightly and talk about how it's relevant to us today. Because if you're a JavaScript application developer like myself, then when Webpack came on the scene, you probably noticed that it was automatically generating these URL schemes for you. Now, Webpack wasn't the first one to do it. I was doing it in Grunt and Gulp before then, but Webpack has certainly put it in from day dot, and everything since Webpack has also used it. This is really important because this has a hash of the content inside the URL, meaning that the content can't change unless the URL does. That's perfect for a CDN. So setting this cache control immutable means that everybody knows once they've seen that file once, they never have to check the origin server again. And if you're building client-side apps, that's kind of enough, right? Because you can serve an empty page and then a whole lot of JavaScript, and then the app will run in the browser. And if you do bundle splitting, every time something changes, you just update the bits that change. Now, not every app needs to do better than that, right? If you're building an app that people are sitting there for hours using at a time, it doesn't really matter how many seconds it takes to start. And if you're building like a banking app, then it doesn't really matter how bad it'll be, because you still have people's money and they'll walk over broken glass to get it. But for the rest of us, and any time where you have to start to dipping into more performance sensitive stuff, this isn't fine. You have to start to embrace a global network. And I would even go so far as to say, unless you make CDNs a part of your deployment process, you can't build a fast website. So I wanted to talk about a couple of things, because this is a performance talk, but it's very tempting to say, hey, you have to throw away everything you've done before in order to get better performance. Whereas the truth is, CDNs are actually really great. So if you've got one in front, there might be a couple of things that you can do with it. The first one is the sMaxAge header, which is one of personal favorite of mine. Now, max age just means if this thing is not this old, so that number means 1 year, then you don't have to come back to the origin to check for a new version. Max age 0 here means the browser never trust your old version, always come back and check. But sMaxAge is telling the CDN, you have this copy for a year, you can always handle these requests. So you get the browsers checking in, but they're only going as far as their nearest CDN node. The trick with this is that then you need to include some way of telling the CDN that this content has changed when the content changes. Now, this isn't for those fingerprinted assets. This is for your index.html, anything that rapidly changes. But CDNs are really good at updating what's cached. And so sending them a command to say, hey, these URLs have now changed as part of your deployment gives you really, really good performance and very low load onto your origin. Kind of the next version of this is the stale while revalidate header. This tells the CDN that while the version it has cached might be expired and it needs to go and get a new version, it can keep sending the old one for this length of time. So for a year, it can serve the old version. But the sMaxAge of 60 means once a minute, it needs to go and check for a new version. And this sort of inverts the process. The CDN is now pulling from the origin server, but at a really low kind of rate. All of your users are still accessing the, still just hitting their local CDN. So they're getting really fast response, but your content is never more than 60 seconds out of date. The other advantage of this is that you could have millions of people accessing your website, but your origin is still only seeing one request every 60 seconds from every node across the network. This I love using, and I think it's great, but I'm expecting it to have been a much bigger part of people's deployments if it wasn't for part 2, which is the rise of Jamstack. Jamstack is one of the bigger trends in recent web deployments, and I think it's popular because, well, it kind of hides a lot of the details around CDNs and gives you something much simpler to understand. So traditionally, you had this CDN that sat between your users and your origin, but you needed all three to kind of be there. You needed your origin to be live, and the CDN was only just an enhancement. Jamstack, while it has the same structure, changes that. And now it says that the CDN is your host. Your CDN is responding to every request, but in order to change content, you now tell the CDN, here's the new copy of the file. It's a subtle change, but it really increases the stability of your site. And I think stability is the best thing about Jamstack. Because you're only deploying static files and you're doing it globally, your resilience to load is much increased. There's no route that's going to hit your origin server because you don't really have an origin server anymore. And so you can kind of sleep easy because serving static files is really simple. In terms of performance, it can be a lot better than what you're doing at the moment. But I will say that there are definitely some things that are difficult to do in a static deployment, which means you end up leaning on client-side JavaScript a fair bit more. And so you can end up with a worse performance in some cases, even by going to a static site. The same sort of story applies with complexity, where deployments are now super simple because you're just throwing static files across a wire, but generating a perfect static snapshot of your build takes a bit of extra effort. And then you have to figure out what to do with the dynamic pieces and how to run them efficiently in the browser. But one of the things I dislike the most about Jamstack is its inefficiency. Because in the traditional sense, every change to your site needs to generate the entire site afresh, which means a 10,000 blog post site with changing one route can be taking 30 minutes, an hour to rebuild. This is a real impediment to iterating quickly on your code, and it's something that needs to be addressed. The way it is addressed is by the same companies who are pushing Jamstack as a methodology are also offering platforms that solve some of these pain points in what I'm kind of calling the integrated edge. So they don't just take the simple Jamstack approach, they also have some strategies around publishing or rebuilding only the things that have changed, or only publishing the things that have changed, or in Vasel's case, actually telling the CDN, giving strategies that do something very similar to stale while revalidate by running your build kind of as a server in the background. These are all really, really good, but for me, it's not quite as good as what we had before with the purely standardized HTTP world. There are a few things that I think weaken Jamstack's appeal. And the first is just how locked in all of these vendors make you. Everything that's made easier at every step from in a Jamstack world has more and more baggage associated with it. For example, this is a couple of snippets that go into a Netlify config file where you're doing simple redirects or setting a few headers on a few routes. This is something that you could have done with a few lines of code, or if you had a node server or any kind of web server, that now you have to put into to platform-specific config. It's not the worst in the world, but every time you reach for this to solve a problem, you're getting further away from something that you can pull elsewhere. The other thing is that there's been a tendency towards looking beyond Jamstack into this idea of a hybrid framework where some pages are static and some pages are dynamic. But something I'd like people to just sort of be a bit more aware of is that when you're thinking about performance and you're thinking about moving from static to dynamic, there can be a huge performance disparity between the two. I actually ran a benchmark this morning on one of Vasel's a Next.js app running on Vasel. The data here I'll skip over, but it's more for the slides later. But you can see the impact or the difference between a static and dynamic route here, where dynamic in the best case is still a few 100 milliseconds worse than static. But as you get to the higher percentiles, so these are 50% or 25% of your audience are getting more and slower response times up to about a second. And this is a time to first byte, right? This is before the rest of your app has even loaded. This is just on top of everything else. Now, this is a synthetic benchmark, right? And I encourage you never to trust a synthetic benchmark or any benchmark that you haven't run yourself and understood the constraints. Do run these tests yourself. The only point of the numbers here is to show that there's a huge difference between the rendering pipelines between the static and dynamic halves of Vasel's platform. And that's something that might not be obvious considering how easy it is to move from one to the other. All that is to bring us to the future, well, which is also the current, but not evenly distributed, which is the dynamic edge. So rather than looking at the CDN architecture and saying, well, let's make a static CDN, a static edge, and send updates to it like we do in Jamstack. If we have a dynamic edge, then we don't really need an origin server at all. In fact, the whole point of a CDN was to run close to our users. But what if this was where we hosted it? What if we hosted it everywhere in the world? I mean, it's just front-end code after all. It's not massive databases and all these sorts of things. So this is a new category of tool. Now, I'm going to be talking about Cloudflare Workers because Workers in this space is the leader, but this is a category that's going to keep growing. And while some of these competitors' products will do some of these things, but not all of them, I expect them all to get better over time. And you shouldn't think that you're just opting into one vendor because this is just a new way of running code at the edge. For Workers, there are a few things to know, right? There are you have a 1 megabyte script limit because it's deployed to every location that Cloudflare has. But on the other hand, it is running in all 200 locations. It runs in a V8 container, not Node.js. So it's JavaScript, but you need a new mental model. And there are some tighter CPU and RAM limits, although for general purpose stuff, it should be okay. One of the exciting things is that there's no cold start impact because of this different architecture. So when we saw on that Vercel graph, that 1 second bump, that was because of Amazon Lambda under the hood doing a cold start for a new request. On Workers, that cold start is actually so quick, it happens in the background while your TLS handshake is underway. So while your browser is negotiating with its nearest server to encrypt an SSL connection, the worker is spinning up in the background. So by the time the request body actually comes through, your worker is ready to go, effectively making cold starts invisible. Now, one version of this feature is that these new Edge frameworks come out, and these are all really cool. Nuxt.js isn't quite released for its Edge serverless one yet, but it will be quite soon, where these new frameworks offer cool new things, and you switch your app across to them and have a great time, really great performance, and that's the next history. But for me, that's not quite good enough. I think we have an opportunity to do better, because we're going from a model where the CDN is just capable of caching and therefore just capable of static things to being able to run your entire application. So why do we need to lock ourselves in to only frameworks that are designed for that? I've been trying to bring about this future where anyone can access their code and port it across to running at the edge with the project front-end application bundles. The architecture of a fab is that it should be able to be any application using any framework, no matter how static or dynamic it is, should be able to be compiled down to a fab. The fab is a single server entry point and a directory full of assets. The key is that fabs can be deployed to brand new global edge locations, as well as anywhere else. Basically, anywhere that can run JavaScript, anywhere that can run Node is completely backwards compatible. The idea being that you can test whether your application right now is compatible with fabs, maybe use it internally, maybe test it on the edge and see how it performs before deciding to really adopt that, because there might be parts of your app that you want to rewrite in order to get most performance. It's great to be able to verify that things are actually running really well. Now, I don't have too much time to go into this, but when a fab gets deployed, in a traditional way, it does run differently to when it runs on the edge. Some of the performance characteristics are much better running at the edge. In the traditional employment, we've tried to design it so that it runs as well as it can, but the real gains are if you start using something on Workers. And like I did another benchmark this morning of Next.js running inside a fab on Cloudflare Workers. Again, these numbers are just for the slides. It's easier to see on the graph. Static performance is pretty good. Dynamic performance is okay. Next.js is actually kind of the worst use case for fabs at the moment. It's kind of the most bloated, or the most chunky, I should say, framework. It's really designed for Node.js. It's really not designed to run inside a fab. So we have to do a lot in the compiler to actually make it compatible, which is why you see such a big disparity between static and dynamic performance here. It's something that we will be actively working on and trying to improve. But if you use fabs with other frameworks, you should see even better performance than this. And just to compare, we're seeing extremely similar static performance to Vercel, but the dynamic performance is clearly a lot better. There is while there is still some to the long tail 75% percentile slowness, you're still running at worst case 400 milliseconds instead of worst case 1.5 seconds. And with that, I encourage you to check it out. I encourage you to go to fab.dev or the GitHub and have a look, trying to compile your app to it, see if it will run on Workers. Workers is available at workers.dev. If you go to fab.dev, there's a Discord there. You can get in touch with me and I'll help you if I can. But other than that, thanks for having me, and time for questions.